Hello, the aim of this video is to show you how we teach maths in Year 5. We will be looking at the 4 operations: addition, subtraction, multiplication and division, and we will be looking at an example of calculation and reasoning for each of these operations. We will begin with addition. In Year 5, children are expected to be able to add 4 or more digits together using the column method. When using the column method, it is very important to remember to start on the right-hand side at the lowest value digit. In this case, it's the ones. We would start on the right side so that we can carry any digits that we need to add into the next column. Let's begin. 9 add 3 is 12. That shows us that it's 2. Our 2 goes down and we would carry our 1. It doesn't matter where we carry our 1, we can carry it below or we could carry it up at the top, as long as we remember to add it in afterwards. Personally, I prefer to carry it below. We then move on to the next column. 3 add 2 is 5, and we mustn't forget to add that 1 that we carried. 5 add 1 is 6. 8 add 6 is 14. We put down our 4 and we carry our 1. 5 add 7 is 12, and let's not forget to add our 1, 13. Our 3 goes down and our 1 in the next column. Because we have nothing else to add here, we just pop it straight into the column rather than carrying it. So that is how we would solve a simple addition calculation question. Now let's have a look at a reasoning question. This reasoning question says, Jack says, when I add 2 numbers together, I will only ever make up to one exchange in each column. Do you agree? Explain your reasoning. For this question, the children would be expected to have a little look at how we would add numbers. When we add numbers using the column method, we will only ever get to add 1 exchange in each column. That is what the question is asking us. So what we need to do there is we need to look at our 2 biggest digits and have a go at adding them together. If we were to add 2 numbers using the column method, the biggest digits that we could possibly add together would be 9 and 9, which would give us 18. So therefore, the biggest digit that I would be carrying over into the next column would be a 1. This shows that Jack is correct. In order to explain my reasoning, I would then write a little sentence saying, when adding digits together, the biggest digits which I would ever have to add are 9 and 9, because when we put things in the column method, you cannot have more than 9 in each column. And therefore, as that gives us 18, I would only ever have 1 exchange in each column, meaning that Jack is correct. We would expect the children to show this using a sentence and perhaps using some digits as an example written down. To just have the digits 9 plus 9 equals 18 written down without any explanation would not be answering the question fully. The children would need to answer the question fully by explaining why they have written down 9 plus 9. In short, they have written 9 plus 9 because 9 is the biggest digit that you would ever have in any one column. Let's have a look at our subtraction question. This question, we have 10,037 take away 9,329. I have chosen this number because we are going to need to be exchanging from zeros. This is something which is expected in Year 5. Again, in Year 5, children are expected to subtract 4 or more digits from each other, and they will be expected to exchange digits in order to do this. Again, similar to addition, we must make sure that we start with our right hand side at the lowest value digit. In this case, 7 and 9. 7 take away 9 we cannot do because 7 is smaller than 9. This means we need to go to the tens column and we need to exchange one of these tens for 10 ones. So we will no longer have 3 tens, but instead we would have 2 tens. And we would now have, because we're moving 1 10 into our ones, we would be moving 10 ones, making it 17 ones. 17 take away 9 is 8. We can now move on to the tens column and have a go at subtracting those digits there. 2 take away 2 is 0. Now moving into our hundreds column, we can see that we've got 0 take away 3. Again, this cannot be done as 0 is smaller than 3. So we need to go to the next column into our hundreds and we need into our thousands and we need to exchange. However, in our thousands, we also have a 0. You cannot exchange from a 0 as you can't borrow anything if there is nothing there. Which means we then need to go into our 10,000s where we've got our 1. So we're going to exchange 1 10,000. We can only exchange into the next column. So our 1 10,000 is going to need to go into our thousands column. It cannot go straight into our hundreds column. So we will now have 10 thousands. From there, we can then go back to our hundreds and see that we can now exchange from our thousands column as we have 10 thousands there. So we can exchange one of our 10 thousands, leaving us with 9 thousands and 10 hundreds. 10 hundreds take away 3 hundreds will leave us with 7 hundreds. And 9 thousands take away 9 thousands will leave us with 0 thousands. And so our answer would be 708. Similar to addition, we will now go on to complete a subtraction reasoning question. Rosie completes this subtraction incorrectly. When we are doing addition, subtraction, multiplication and division, a lot of the reasoning questions that we have are to explain mistakes that other people have made. This is the opportunity for children to show that they understand how subtraction, addition, multiplication and division actually work. They should be able to look at this number sentence and spot where Rosie went wrong. They should be able to explain Rosie's mistake and correct it also. So what we would expect the children to do here is to look at our numbers and to have a go at subtracting that themselves. So 28,701 take away 7,621. Now let's have a go at subtracting. 1 take away 1 is 0. 0 take away 2, we cannot do that, so we are going to need to exchange. We're going to have 6 hundreds and 10 tens. 10 take away 2 gives us 8. 6 take away 6 is 0. Now here, children should automatically be able to see that we have got a different answer to Rosie. They will be able to note that although Rosie exchanged in order to subtract in her tens column, she did not remember to change the number in her hundreds column. So she did not complete her exchange correctly. Rosie has forgotten that she exchanged from her hundreds. This is the answer which we would expect the children to notice. They can see that the 0 is different to the 1, and therefore they should be able to note that Rosie forgot to change her hundreds. She forgot to exchange them completely. If we continue on that question, we will see that the rest of it is correct. 8 take away 7 is 1, and 2 take away nothing is 2. So that is the only mistake that Rosie has made. We would encourage children, even after they have noted the mistake, to complete the question in case Rosie has made more than one mistake. In Year 5, in multiplication, children are expected to multiply 4 digits by a 1-digit number, but also multiply 4 digits by a 2-digit number. So in this example, we will be first of all doing 4 digits by a 1-digit number, and then in the next slide, we will go on to complete a question involving multiplying by a 2-digit number. So, in order to begin this, similarly to addition and subtraction, when multiplying, we will start at the lowest value. So we will start with our ones and multiply them first with our ones. We will then move along and multiply our ones by our tens, then by our hundreds, and then by our thousands. So 5 times 8 gives me 40. I will put down my 0 and I will carry my 4. 5 times 4 gives me 20. Now, I then need to remember to add my 4 which I have carried below. One thing to note with multiplication is that when it gets to multiplying by 2 digits, if we carry our digit below, it can get very confusing and complicated. So we do encourage the children to carry their digits above. So 5 times 4 gives me 20, add my 4, that gives me 24. I place my 4 and carry my 2. 5 times 3 gives me 15. Add the 2 which I carried, 17. Put down my 7 and carry my 1. 5 times 4 gives me 20. Add my 1, 21, and pop both digits down as I have reached the end of my calculation. Now, as we move into the next question, you will understand what I mean when I say that the benefits of carrying above rather than below. When we multiply by 2-digit numbers, we are going to end up having 2 digits which we will need to multiply together. But just as before, we're going to begin with our ones. We're going to multiply our ones across the digits at the top, beginning with the ones, then the tens, then the hundreds, and then the thousands. Only once I have multiplied my ones by all of those digits do I then move on to my tens. So let's begin. 5 times 1 gives me 5. 5 times 4 gives me 20. Pop down the 0 and carry the 2. 5 times 3 gives me 15. Add my 2. 17. I then cross out my 2 so that I don't get confused by the numbers I am carrying when I multiply by my tens. So I pop down my 7 and carry my 1. 5 times 7 gives me 35, add 1, 36. And again, I make sure to cross out that number that I have carried, as I don't want to get confused when I move on to the tens now. Now, because I am now multiplying by tens, I need to remember to pop in my placeholder. When multiplying by 10, you will never have any ones as a response, because if you ever multiply a number by 10, you will always end up with something ending with 0. So you pop in your placeholder of 0 to show that you will not have ones, and to show that you are now multiplying by 10 and not by ones. When we then multiply, we can see 20 multiplied by 1 would give me 20. So I can put my 2 in my tens column to represent 20. 20 multiplied by 40 gives me 800. So I put my 8 in my hundreds column to show. When we do this in class, we will often then say 2 times 3 so that the children don't get too confused by the hundreds, the thousands and the 10,000s. But the children must understand that when we are multiplying, for example, our 2 times 4, it's not actually 2 times 4 that we are doing, but 20 times 40, which is why our 8 goes in our hundreds column. So then 2 times 3 gives me 6, and 2 times 7 gives me 14. Now in that question, I didn't have to carry any digits. However, if I had to carry any digits, carrying them above and then having crossed out the digits before would make it a lot clearer. If I carry my digits below, then they're going to get confused with the numbers that I come up with after multiplying by my tens. And occasionally children will then accidentally add those into their final question, and that is where they will make their mistakes. We now need to add these two numbers together. So 5 add 0 is 5. 0 add 2 is 7. 7 add 8 is 15. Carry our 1. 6 add 6 is 12. Add 1, 13. 4 add carry your 1. 3 add 4 is 7. Add your 1, 8. And 1 add nothing is 1. So that is the final answer. So we did our number multiplied by 5 in our first instance, and then we multiplied by 20 in our second instance. By adding those together, we have now multiplied by 25. Now moving on to our reasoning question. It is another spot the mistake. It is important that the children are able to spot any mistakes that have been made. So again, in this case, we would expect them to complete the calculation and note any mistakes that have been made. So beginning with our ones, we would do 3 times 4 gives me 12. Carry your 1. 3 times 3, 9. Add your 1, 10. 3 times 5, 15. Add your 1, 16. Carry your 1. 3 times 2, 6. Add your 1, 7. Now let's go back and check. We can see that the mistake has been made here. What has been done here is the person completing the calculation has actually forgotten to add on their carried 1. From when they did 4 times 3 as 12. They did 3 times 3, but they forgot to add on that digit, making it 10 instead of 12. Sorry, 10 instead of 9. They placed down 9 when it should have been 10 that they placed. Let's continue and see if there are any other mistakes. We will now be moving on to our tens column. When we move on to our tens column, we need to remember to pop our placeholder in straight away. We can see here that the person completing this has forgotten to add in their placeholder. So instead of there being their 0 to show that we are multiplying by 10, they have only multiplied by 2 instead, and they have forgotten their placeholder. 2 times 4 would give me 8. 2 times 3 would give me 6. 2 times 5 would give me 10. 2 times 2 would give me 4 and 5. So we can now note that the mistakes made are that the person has forgotten to add their carried digit in their tens column when multiplying by 3, and they have forgotten to add their placeholder. This is what we would expect the children to explain once they complete this question. The person has forgotten to add their carried digit in to 3 times 3 and to add their place holder. Finally, we will move on to our division. In Year 5, we divide up to 4 digits by a 1-digit number. And we use the bus stop method to do this. When doing our division, we encourage the children, if they are not that confident in their tables, to write down the tables of the divisor. So, we begin by writing down our tables 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. If the children have written down their times tables, then it makes it much clearer when dividing using the bus stop method, as they can simply refer back to the digits that they have written in their times table. So the first thing we do, division is the opposite of addition, subtraction and multiplication. In division, we start with our highest value. So we would start by dividing our 7 by our 3. So we would say how many groups of 3 can be made in 7. We would then encourage the children to find the number in their multiplication closest but not bigger than 7. So the children will then see that the number in the 3 times table, which is closest to 7 but not without being bigger, is 6. And that is the same as 2 times 3. So you can see that 3 goes into 7 2 times. Now 2 times 3 will give us 6, so we then need to figure out how many do we have left over. To get from 6 to 7, we have 1 remainder. So we would need to carry our 1 over into our next column. How many 3's go into 13? Again, we would tell the children to find the number in the 3 times table, which is closest to 13 without being more. In this case, it is 12. And that is 1, 2, 3, 4 times 3. Again, we would ask the children to figure out now how many are left over. So to get from 12 to 13, what is left over? And it's 1 again. Now 3's into 14. Again, the closest number is 12. 4 times 3 gives me 12. And how many more would I need to get me to 14? 12, 13, 14, 2. So I would need to carry over my 2. 3's into 28. We would need to find the number closest to 28 without being bigger, which is 27. 9 times 3 gives me 27. How many is left over? Well, from 27 to 28, that's a difference of 1. So we would need to put a remainder 1. Children in Year 5 are expected to be able to find remaining numbers. We also encourage them to be able to put them as a fraction and a remainder. Okay, so in this case we've put it as a remainder of 1. If we wanted to put it as a fraction, we would simply take the divisor and that would be our denominator. So as a fraction, our remainder would be shown as 1/3, 2,449 and 1/3. In our reasoning question, Jack is calculating 2,240 divided by 7. He says you can't do it because 7 is larger than all of the digits in the number. Do you agree with Jack? Explain your answer. The children should be able to understand that 2,240 is larger than 7 and therefore can be divided by 7. They would know that it is not the individual digits that matter when dividing, but the number as a whole instead. They could then also have a go at doing the question to prove that Jack is wrong. 7s into 2 you can't do, you've got a remainder of 2. 7s into 22, the closest number is 21, which is 3 times 7, and you would have 1 left over. 7 into 14 is 2, and 7s into 0 is 0. So the children should be able to explain Jack is wrong because when dividing if the whole number is bigger, then it can be done. And then they might add to that to have a look at the question which they did and explain Jack would need to carry over digits in order to complete this question. I hope that this video has been useful and that it helps you when supporting your children at home with their maths learning. In maths in Year 5, there are lots of different aspects, and multiplication, addition, subtraction and division come into every aspect of our learning. It is extremely important that the children do know their times tables, as most of the things that we do in Year 5 involve multiplication and division of some sort. Thank you for your time watching this video, and thank you for your continued support of your children in Year 5.